Welcome to qnawire.
In this problem, we have this function which represents the proportion of the population that has heard a rumor as a function of time. And what we want to do with it first is find the limit as t approaches infinity. So as time is approaching infinity, what proportion of the population has heard the rumor? So let's imagine that we have infinity plugged in for t. Then we have e raised to the negative k times infinity, and that would be e to the negative infinity, and that would be a number that is incredibly small. That's like 1 divided by e to the infinity, incredibly close to 0. So a times that number is incredibly close to 0. So 1 plus something incredibly close to 0 is very, very close to 1. 1 divided by 1 is very, very close to 1. So we could say the limit is 1. And what that means is that 100% of the population has heard the rumor when time is approaching infinity. And that makes sense. Okay, in part B, we want to find the rate of spread of the rumor, and the rate of spread would be the rate of change, and that would be the derivative. So what we're going to do is take the simplified version of the function, where I wrote it here instead of writing it as a quotient, I wrote it to the negative first power. And so we'll use the chain rule on that. So we bring down the negative 1, and we raise the inside to the negative second power, and then we multiply by the derivative of the inside. The derivative of a e to the negative kt would be a e to the negative kt multiplied by negative k, the derivative of the exponent. Now we can simplify that derivative by changing it back to a quotient. Okay, now that we have that, what we want to do is graph the original function, plugging in some specific values. So the value for a is 10, and the value for k is 0.5, and when we substitute them in, we get this function here. So we're going to put that into a calculator, and then what we want to do with it is use it to figure out how long it will take for 80% of the population to hear the rumor. So 80% would be represented by a proportion of 0.8. Okay, so let's grab a calculator, and then we go to y equals, and here we have our function. And for a window, I've chosen to try 0 to 20 on my y-axis. I'll just go by 5s as a scale. Or sorry, that's 0 to 20 on my x-axis. And then negative 0.5 to 1.1 on my y-axis. So let's take a look at that graph. So that makes sense that as we get closer to the full population reaching the point of having heard the rumor, it's just going to taper off and be flat. So the way we can find the time when it reaches 0.8 is to go back to y equals and go to y2 and put a 0.8 in there for y2. That gives us a horizontal line at a height of 0.8. And then we can find the point of intersection. So we go into the calculate menu, which is second trace. We go to number 5, intersect. We put the cursor on the first curve, press enter. Put the cursor on the second curve, press enter. And put the cursor near the intersection point, press enter. And here we see at the bottom of the screen, the units would be hours in this case, so we have 7.4 hours roughly for it to reach an 80% rumor saturation point.